Hello students, myself Jayesh Prajapati, Assistant Professor of LJ Institute of Engineering and Technology in the Department of Electronics and Communication. In this video, we are going to learn about Industrial Drives and Control, Unit number 3, that is DC Control Drives. In this unit, we have already discussed the half control, full control, semi control drives. Now, in this session, we have to discuss the content, that is closed loop control of drives, that is current limit control, closed loop speed control, closed loop torque control, closed loop position control, and phase locked loop, that means PLL control scheme, then closed loop speed control of multiple motor drives. So that is a closed loop operation of control drives that we have discussed in this manners in this session. So let us start. We can say that a closed loop control of drives, that means the feedback loops in electrical drives may be provided for protection, enhancement of speed of response, and to improve steady state accuracy. So that is a three major requirement for closed loop control of DC drives. That is in the electrical drives, the feedback system that is given to the electrical drives, that is for protection and then speed response and to improve the steady state accuracy. Now we have to discuss each and every closed loop control system. So let us start first the current limit control. The current limit control scheme is employed to limit the converter and motor current below a safe limit during transient operation. So the current limit control scheme, that means what? To limit the converter and motor current below the safe limit, because sometimes the current will be very high. So we have to provide some current limit. So that is a current limit control scheme. It has a current feedback loop with threshold logic circuit. Means in this current feedback loop, one of the threshold limit. So we have to select the maximum value. If above the maximum value the current will be go, then it will be give feedback to the main system. There will be current will be high. So some action will be created. So that is a current limit control. Then as long as the current is within a set maximum values, the feedback loop does not affect the operation of drives. So that means what? If it is set to the maximum value, but it is at the maximum value, below the maximum value, that will be not affect. But above the maximum value, then it will be affect. Okay. So if we see the system of current limit control, then you can see in the figure the current limit control scheme. First, that is the input voltage. Then we have to take one summing point. Then we have to give this to the controller. Okay, our main controller. Then we have to give to the converter. Okay, any converter, rectifier, inverters. Okay, AC to DC converter or AC to AC converters. Okay, any converter. Then it is give to the motor. Then load. Okay. Now here in this session, you can see we have to measure the motor current by the current sensor. Then we have to give this current value to the threshold logic circuit. That is a threshold logic circuit. That means in the figure you can see that is a zero value and that is a maximum value. So that is a threshold logic circuit. So if motor current is at the threshold logic circuit, then it will be not affect. But it above the threshold limits, then it will give feedback to the main controller system. So here we can give this closed loop system. Here you can see that is a one line system. Okay. And here we can give a feedback to current sensor by motor and it is given to the summing point. So that is all closed loop operation of a current limit control. So here we have to take positive and negative terminals. Okay, that is positive, that means voltage means current will be given to this circuit, and if it will be above, then we have to minus this value. So that is a closed loop system. So that is a block diagram of the current limit control scheme. In this figure, you can see the wall block diagram, and during the transient operation, if current exceeds the set maximum value, then the feedback loop becomes active and current is forced to below the set maximum value, which causes the feedback loop to become inactive again. Okay, so it is a current exceed maximum value again, then it will again brought below its action and the feedback loop. So that is the main current limits control. It is used during the starting when the current is fluctuate around the set maximum values. So sometimes transient operation, that times the current value will be increase maximum and decrease minimum. So that times this current limit control is used for the drive system. So that is the main important of the current limit control scheme. Now we have to discuss the closed loop speed control scheme. Okay, that is a closed loop speed control. We have to measure now the speed. So the closed loop speed control employs the inner current control loop with outer speed loop. Okay, in this loop, closed loop speed control, we have to employ one current limit control and also one speed loop control, because speed is dependent by the current. Okay, so we have to use two loop in this system. Inner current control loop is provided to limit the converter and motor current or motor torque below the safe limit. Okay, that is current loop, that means to limit the converter and motor current and torque also. So because current is proportional to torque, so torque means that is force, so that is also proportional to the speed. Okay, so in some scheme the current is controlled directly, but in other scheme it will be controlled by indirectly. For example, if a variable frequency induction motor drive, then current is controlled by the slip, because we know that the speed ns that is proportional to this slip also. Okay, ns minus n divided by n, that is a slip. So we have to control the variable frequency of this motor by the slip. So that times we directly control, but sometimes it will be controlled by indirectly also. So that times we have to take this time of control loop system. Now, as increase in the reference speed omega star produce a positive error delta omega m, speed error is produced through a speed controller and applied to the current limiter, a speed controller, and applied to the current limiter, which saturates even for a small speed error. So that is the actual closed loop system sentence, because whenever the speed will be increased above the maximum value, then it will be some error, then it will produce into speed controllers. So that is applied to the current limiter. Okay, now in the closed loop system you can see in the speed control system, first we have to give the actual speed omega star, then summing point, then you can see that is given to the speed controller. Okay, then there is some error delta omega m, that is given to the current limiter. Okay, that is the one current limiter that can limit the currents. So the output will be the current I star. Okay, that is given to also the one summing point. Then it is given to the current controller, then it is given to the converter. Okay, that is actual the current control limits. Okay, then converter is given to the motor and the load. Now you can see the motor can measure the current sensor, measure the current by current sensor, and it is given to the current limit control. So the wall system, that is a current limit control. Okay, Now the wall we have to create the closed speed loop control scheme. In this speed control scheme we have to add one current limit control scheme. Now you can see that is a speed sensor. Okay, here we have to measure the speed omega m, that is given to this summing point, and this positive minus negative. Okay, so that is a closed loop speed control scheme. You can see in this figure, if the limit set current for inner current control loop, a value corresponding to the maximum allowable current. Okay, now the drive accelerate at a maximum allowable current, that is a maximum values. Now you can see that is the actual speed omega m. Okay, here omega m is given to the speed controller. Okay, if some kind of errors delta omega m is created, so that times it will be minus from this. Okay, and it is given to the speed controller, and that is a current limiter that can limit the current. Okay, and here we also provide motor current limit control, the similar. And similar here we have to measure the speed by this motor shaft. Okay, from the motor shaft we have to measure by speed sensor, and the if speed is above our maximum set value, then it is give to the summing point. Okay, so it will be minus from this omega m star. So current and speed controller may consist of PD, means proportional integral, PD and PI, proportional integral or proportional derivatives, or PID, proportional integral and derivatives controller, depending on steady state accuracy and transient response requirement. So whenever you use MATLAB, that times if you have to create a closed loop speed control system for your analysis, that times you have to use PID controller. Okay, proportional integral and derivative types blocks. Okay, so that times if we measure the speed, then we have to calculate some errors. That times you have to create the system, that time you have to use PID controller also. So that is a block diagram of closed loop speed control system. You can see in the figure. Okay, now we have to discuss the closed loop torque control system. A closed loop torque control scheme find application in battery operated vehicles, rail cars and electric trains. Okay, so that is applications of closed loop torque control scheme. Now you can see the drive presses the accelerator to set torque reference T star. Through the closed loop control of torque, the actual motor torque T follows torque reference. Okay, so here the speed feedback loop as present through the driver. By putting appropriate pressure on the accelerator, the driver adjusts the speed depending on the traffic road condition, car condition, his lifting condition and speed limit. So that times if you have to control by using torque control system. So that is the actual application of the vehicles and cars and trains. Okay, now we have to see the block diagram for closed loop control system. You can see first that is the input T star. We have to take T star, that is the main reference value. Okay, then given to the summing point, then the torque controller. Okay, then we have to given to the converter, then we have to give to the motor, and from the motor shaft we have to connect any kind of load. Okay, now the from motor we have to measure the by using torque sensor, that is we have to measure the torque, and it is given to this also a threshold limit controller. Okay, and it is given to this here. Here we have used a threshold limit, but sometimes it will be not used. Okay, you have to give direct by using torque sensor to this. Okay, and that is positive negative terminal for closed loop control torque control system. So that is the actual block diagram of closed loop torque control system. So in the every block diagram you can see one of the reference value that is given to the controller, then converter and motor load, and from the motor shaft or motor terminal we have to measure current, speed, and it is given back, feedback system is given back to the input side. Okay, that means we have to protect, and if we have to limit sometimes, and we have to control, and if we save powers set times, the drive system will be used that times of closed loop control system. Okay, now in the next, that is a closed loop position control system. In this system you can see it consists of closed loop speed control system with an inner current control loop inside an outermost position loop. The current and speed loop restricts the current and speed within the safe limit. Okay, then position controls are required in number of drive applications like feedback drive in machine tools, screw down mechanism in rolling mills. So that are the applications areas of position control system. Now the position control system, that means if we have to reduce the effect of non-linearities in the converter, motor and load on the transient and steady state performance, that time the positive control system will be useful. Now that is actual application, that here we can see the feedback system, machine tool, screw down, rolling mills. Now if we see the position control system, then the closed loop position control scheme is like this. We have to use position for some angle theta m. Okay, theta m star, that is input reference that is given to summing points, then position controller. Then from position controller we have to give to the speed limiter. Okay, then we have to give inner loop, that is closed loop speed controller. Okay, then it is give to the load, and from the load we have to give to the position control theta m. Okay, and that is positive and negative terminal. So that is the actual block diagram of a closed loop position control system. Okay, so that is a position control system that will be used in machine tools, sometimes rolling mill, the position of these rollers also. So that times the we have to use this kind of position loop control system. So that are the all closed loop position control scheme that we have to discuss in this chapter 3, control of DC drives. Also we have to discuss the PLL, phase lock loop control system, and by multi-motor speed control system, that we will discuss in the next lectures. Okay, thank you.